Okay, Math 2. This is the Unit 8 review worksheet. This is Mr. Trutna from Clovis High School. And there are 50 problems to do on this worksheet. We're not going to do them all. We're just going to do the ones that were circled because those are the only ones that I want you to be responsible for doing. Okay, so number one, we're going to simplify each expression. So we are adding two grouping values. So remember, when you have grouping values, the first thing you want to do is you want to rewrite the problem so that there are no parentheses or grouping symbols at all. And then after you rewrite the problem so that there's no parentheses or grouping symbols, then you want to combine like terms. Okay, so if you notice, I can combine the 7 and the positive 8 together. That's going to give me 15. And then I can combine the positive 2 square root of 3 with the minus, and this is a minus 1 square root of 3. So when you're adding or subtracting radicals together, the thing that you think of is first of all, you think of like terms, and they are like terms, and then you go outside minus outside, so positive 2 minus 1, that's going to be a positive 1, and then you leave the radical alone. So number 1 would be 15 plus radical 3. You don't have to write the 1 there. It's implied, okay? In number 2, to rewrite this problem without grouping symbols, the first grouping symbol, I could literally just rewrite it as it is, and that's because there's a positive 1 in front of that, and if I distributed the positive 1, it's not going to change. But in the second grouping symbol, you have to think to yourself, okay, there's a negative 1 in front of this parentheses or grouping symbol. If I went negative 1 times positive 2, that would make a negative 2. And then if I went negative 1 times negative 4 radical 13, that would make a positive 4 radical 13. Okay, now we combine like terms. I take this whole number 3, I combine it with the whole number minus 2. 3 minus 2 is 1. And then I take the radicals, and since they both have a radical 13 in them, that means that they are considered like each other. So then to add them, I go outside number, positive 2, plus outside number, that would be positive 6, and then you leave the radical alone. So the solution to number 2, 1 plus 6 radical 13. Okay, number 3, write the first grouping symbol or parentheses without parentheses, so it would not change at all. Then once again, in the second grouping symbol, you have to think of it as having a negative 1 in front of it. So if you took that negative 1 and you distributed it and it multiplied it by the negative 4, that would make a positive 4. Then if you took that negative 1 and distributed it into the negative 2 square root of 7, that would make a positive 2 square root of 7. After we rewrite the problem without the parentheses or the grouping symbols, now we look for like terms. The 10 and the positive 4 are like, so that's going to combine to make 14. And then I can combine the 5 square root 7 with the positive 2 square root 7. They're like because they have the same exact radicand. So I go outside number, positive 5, plus outside number, positive 2. That's a positive 7. And then I leave the radicand as itself, or as is. 14 plus 7 square root 7. Number 3, same idea. Drop or get rid of or rewrite the problem without the parentheses. The first parentheses you don't have to do anything with. The second parentheses you have to take this negative 1 and you have to distribute. Negative 1 times negative 3 would make that a positive 3. Negative 1 times negative 7 square root 5 would make that a positive 7 square root 5. Now, after the grouping symbols are gone, we can combine like terms. 5 combined with positive 3 gives me 8. Positive 2 square root of 5 plus 7 square root of 5. I go outside number plus outside number, so positive 2 plus 7 is 9, and then you leave the radicand as it is. So that would be 8 plus 9 square root of 5. Okay, in number 5, we're going to do the same thing. We are going to simplify the expression, and then after we simplify it, we're going to denote if the answer is a rational or an irrational number. Okay, so in the first problem, I'm subtracting. I have parentheses, so I want to rewrite the problem without parentheses first and foremost. Once again, I have this negative 1 here, so I'm going to have to distribute the negative 1. Negative 1 times 2 square root of 3 is negative 2 square root 3. Negative 1 times the negative 2 gives me a positive 2. After I rewrite without parentheses, I combine like terms. I think like terms. These two terms are like because they have the same radicand, the 3. Okay, and if you notice, they're complete opposites of each other. That's a positive 2, that's a negative 2, therefore they cancel each other out. And what we're left with is positive 5 plus positive 2, so my simplified expression is 7, and whole numbers are always rational. The next one, 17 square root 5 plus 3 square root 5, we think like terms, they're like, so then you go outside number plus outside number, and then you leave the radicand as it is. So my simplified version here would be 20 square root 5. Okay? Now, because 5 is not a perfect square number, that makes my answer irrational. All right? The next one, the square root of 100 plus 4. You want to simplify this first. Well, the square root of 100, that is a perfect square number, which makes this 10. So really this problem is 10 plus 4, so my simplified expression is 14. Whole numbers are always rational numbers. Okay, my next one right here, I have the square root of 16 times 14. You should recognize the square root of 16 as a perfect square number, and that is 4. 4 times 14 makes 56. That is a whole number, so that's a rational number. Okay? The last one, square root of 7 times the square root of 4. So when you're multiplying radicals, you go outside number times outside number, which would be 1 times 1. That's not going to do anything. And then you go inside number times inside number. So you would go 7 times 4. So your answer is the square root of 28. Okay? Now, you want to see if you can simplify that, because we want a simplified expression. So we're going to take the 28, the radicand, and we're going to factor it down into 7 times 4, and then 4 is going to factor down into 2 times 2. So that means when I take my square root of 78, and if I wrote it in its prime factored form, it becomes 7 times 2 times 2. Okay, now I can simplify it because I need two identical numbers. I have 2 identical 2's. That means those they must go to the outside. So my simplified version is 2, and if you have leftovers, you have to leave them under the square root. There is my simplified version. Now, is that rational? Is that irrational? You look at the radicand. If the radicand is not a perfect square number, 7 is not, that would make it an irrational number. Okay? All right. Number 7 here. Number 7 says from the numbers 3, 5, square root 3, square root 5, 3 square root 5, 3 minus square root of 5, choose 2 numbers that when I multiply them, it is rational, and when I add the same 2 numbers, it's going to be irrational. Okay, so based upon our discussion of how to do this, in order to get, now if you notice, all right, we've got a rational number, and then the next 4 numbers are all irrational. Okay, so I want to figure out how am I going to multiply 2 numbers together that are irrational but make them rational. And the way that we did this was, if you recall, if you take an irrational number and you multiply it by another irrational number, if the radicands are the same, this would turn out to be 1 times 3, outside times outside 3, and then inside times inside 25. Okay, well, the square root of 25 is 5, so this problem turns out to be 3 times 5, so that would be 15. So you can see I took an irrational number, I multiplied it by an irrational number, and I got a rational number. Now when I add these same two numbers together, the square root of 5 plus 3 square root of 5, remember that square root of 5 has a 1, I would take the outside numbers and add them, 1 plus 3, that's 4, and I leave the radicand alone. And that is an irrational number, okay? So two numbers from this list that would satisfy A would be the square root of 5 and 3 square root 5. Okay, number 8. Oh, sorry, B. So now I want to find two numbers. When I multiply them, it is irrational. And when I add the same two numbers, it is irrational. Okay, well this one's a little bit easier because what I could do is I could take two numbers like the square root of 3 and the square root of 5, which are both irrational. I multiply them together, that gives me the square root of 15. You can see that number is irrational. So I multiplied, I got irrational. Now I need to add the same two numbers and it needs to be irrational. So the square root of 3 plus the square root of 5, I cannot add those, so that's equal to the square root of 3 plus the square root of 5, and that answer is going to be irrational as well, because if the radicands are not perfect square numbers, then it makes an irrational number. So those two numbers would work for B. Okay, number 8, I'm going to simplify each expression. I'm going to write the final answer using only positive exponents. So in this problem, I'm dealing with the exponent rules and I have an outside exponent. So whenever you have an outside exponent, the rule is that outside exponent applies to everything on the inside of the parentheses. So that 3 applies to the 2, it it applies to the x squared, and it applies to the y to the 7th power. Okay, 2 to the 3rd power, simplifying this out, 2 times 2 times 2, that's 8. X to the 2nd to the 3rd, you multiply those exponents together, so we would get x to the 6th, y to the 7th, then to the 3rd power, you multiply the 7 and the 3 together, so that would give me 21. That's what number 8 simplifies to. Okay? Same idea with number 9. I have an outside exponent of 2, so that outside exponent of 2 is going to apply to the negative 4. It's going to apply to the x to the 4th. It's going to apply to the y to the 2nd. And then I'm going to simplify this. Negative 4 to the 2nd is negative 4 times negative 4, positive 16. X to the 4th to the 2nd, you multiply those exponents together, so that's x to the 8th. Y to the 2nd to the 2nd, you multiply those, 2 times 2, y to the 4th. There's number 9, simplified. Okay, number 10, if you notice, we start off the problem with an outside exponent of negative 2, and you can't have that. So the first thing you want to do in number 10 is you want to rewrite the problem so it has a positive exponent. Okay? Now the way you do that is if the entire problem underneath the negative exponent is in parentheses, you just reciprocate what's inside the parentheses. So the y squared would go from the denominator to the numerator, and the 3x to the 4th would go from the numerator to the denominator, and when you do that, the negative 2 becomes a positive 2. Now, that outside exponent of positive 2 is going to apply to everything on the inside of the parentheses. So that positive 2 is going to apply to the y squared. That positive 2 is going to apply to the 3. That positive 2 exponent is going to apply to the x to the 4th. Simplifying this out, I get y to the second. You multiply those together. That's y to the fourth. 3 to the second is 9. X to the fourth to the second. Once again, you multiply. So that would be x to the 8th power. So number 10 is y to the fourth, 9x to the 8th power.